Hi, my name is Ryan Langwish, and this is Ludo Lodge, a channel about sparking growth in your journey as a game designer. And if you're new to the channel, this is not the first video that I've done covering Tabletop Simulator. I actually have a whole playlist of topics that may be of interest to you, both scripting and non-scripting. I'll link that playlist down in the description below if you want to check that out. Today, though, I'm going to be actually doing kind of an addendum video onto a previous video I did, which was all about making these custom counter tokens that you see here. And so essentially, I aimed to kind of create a workshop mod that would make it very easy for anybody that would want to add these types of counters to their games that let them, increment and decrement resource counts without having to move tokens around, which is kind of useful when you're making games in Tabletop Simulator. So that video kind of covered how to pull in the mod, how to copy these and use them in your game. And it's all intended to be very easy to use even if you have no scripting knowledge or don't want to get into the scripting side of things. But this follow-up video is actually where I am going to get into the scripting side of it, because I know that for a lot of the viewers watching this channel, you're interested in the scripting side of it. You may be trying to script some of your own games or work on different scripting things, and you may be interested in how does the scripting back end to these custom counters actually work. So in this video, I'm just going to talk through it. I'm going to go into the code and kind of just walk through explaining how it's working and how I put it together, maybe some of the reasoning for how I put it together. And hopefully it's just useful for kind of reinforcing certain things if you've been scripting or maybe learned something new. I found that some of the best ways to learn more is just to look at examples and understand how that specific example works. So without further ado, let's jump in here. Now, if you did not watch the previous video, as I mentioned, it's just kind of a button that lets you, or a token that lets you increment and decrement, and you can also have a -5 or +5, and you can kind of change the styling of it. The only difference between the tiles and the tokens is really just the object in Tabletop Simulator. Tokens allow you to have kind of this transparency. The actual script that's attached to it is literally identical. I just duplicated it into a tile versus a token. But if we jump into the scripting editor here, we're going to see kind of some comments up here. So anywhere you see the double hyphen is just comments of me trying to make this easy to use. And the whole first section of this code here is what I went over in the last video, which is all of these variable names that are in all capital letters. And these are what I'm intending to allow users to change, to kind of tweak the appearance or how the token works. So for example, you could change what do you want the minimum and maximum value to be, and whatever you set that to, it won't let it go below or above those values. And so that's kind of, you don't need to know anything about scripting to get in here and be like, oh, okay, I want the maximum actually to just be 10, instead of that value. That's very easy to kind of understand and change. And that's what a lot of the beginning of this is. We have the allow set from description. That's what allows you to go into the description for the object and type a value. And then if you click the button of the value, it'll set it to whatever you did in the description. So if you want to jump from say 50 to 1,000 or something, that would allow you to do it very quickly. You can customize the colors of the background button of the buttons and the font. And then a bunch of the things here are just the different parameters of the buttons. So the size of the buttons and where is the button positioned relative to the token and how big is the font size on it. And so that's all of this. And if you're interested in, if that's not making sense how that worked, I definitely recommend going and watching the previous video that goes over that. But what we're going to dive into in this video is at this point where it says change code below at your own risk. So this is where it gets into kind of the internals of how this is working that I'm not intending for casual users to edit. This is what they would ideally be editing. But we're going to talk through kind of how it's working. So the first thing we have here is something that should look pretty familiar if you've done any scripting in Tabletop Simulator or seen some of my other examples, which is the function onload. Oops. So onload is a built-in function in Tabletop Simulator that triggers whenever the game is loaded for the first time or reloaded. And so whenever that happens, it's just going to run the code in this function. So it's good for doing a lot of kind of initialization stuff. Here, what we're actually doing is this is where we're handling a couple things. We're handling down here at the end the actual creating of our buttons. But before we do that, we're actually handling kind of a saving and loading. And so what this means is if you're playing a game with these counters and you save the game and come back to it later, all of the counters will remember what value they have. And the reason they're able to do that is because they're going to save and then reload. And so to understand how the load is going to be working, I'm actually going to jump ahead to this function, which is onSave. So this is very similar to onLoad, except it's going to trigger whenever the game is saved. And so when it's saved, what we're going to do here is we're going to create a Lua table. So whenever you see the brackets, that's a table is the name of the data structure in Lua, which just allows you to kind of do these key value pairs of this variable is equal to this value, and you could have multiple variables in a table. In this case, we just have one. We're saying saved count is equal to count. Now this table is completely arbitrary as far as what I would want to put in it. In this case, I'm just putting in like what's the current count of this token counter, and I want to put that into a variable called saved count. Once I have that, that's the table that I'm going to tell Tabletop Simulator to save so that I can reload it later. And so what we're going to do here is the onSave function, it allows you to return a value and with the value being what data you want to be saved. And the reason that's going to be helpful is back when we do onLoad actually has an optional parameter here that will load in the saved data. So both of those are things just defined by Tabletop Simulator. It's defined by Tabletop Simulator that by the API that onSave, you can, if you return, it'll end up being a JSON encoded table. It'll save that data, and then onLoad, if you provide this parameter, it'll load in that saved data into that parameter. So if we look here, we create that Lua table, which we're just putting any information we want to save. I could put like a ton of different values, and if you had a really complicated game, you might be saving a bunch of different things. But then I have to actually encode that into the JSON format. So if you're not familiar with this, it's just like a data transfer protocol for how to structure the data. And it's a very human readable. You might also be familiar with XML. If you've seen some of my other videos, actually, the UI in Tabletop Simulator uses an XML structure, which is all the angled brackets, like HTML is an example of an XML-like syntax. So JSON is just another format that's kind of just very similar to a Lua table. Honestly, it's just got a little bit different format. So all we're doing here is we're telling the JSON library, which is something that's included in Tabletop Simulator, to call its encode function on our data, which was that table that we constructed. And so that's just taking the Lua table and converting it into the JSON equivalent of that Lua table. At that point, we're going to return that saved data, which is telling Tabletop Simulator, take that JSON blob and store it. So that way, in the save file, when we come back in, and this gets back to our onLoad, it's going to load that JSON data into saved data. So now on this end of things, all we need to do is first we see, okay, do we have any saved data? We're going to say if saved data is not equal to an empty string. So the exclamation equal is the Boolean operator for not equal. So if it's not equal to an empty string, that means we have some data there. So if that's the case, the first thing we want to do is we want to decode the JSON. So we got to kind of turn it into JSON to save it, but then we want to convert it back from JSON when we get it at this point. So doing decode is going to allow us to get it back into that Lua table format. And at this point, then we are going to look in that Lua table and load that value back in and do what we want with it. Now this line is going to look a little crazy here, and actually Tabletop Simulator for some, oh, now it's working. Sometimes when I'm in here, this scroll bar doesn't work for whatever reason. This line here might look a little intimidating with math max, math min is doing all this here. But let's break it down from kind of the innermost parentheses. So ultimately what we're trying to do here is we're trying to take what was in the save file and set it to our count for this counter so that it's the value it starts with. And so if we look in here, we can see loaded data, which that was the table that we got from the saved data and decoded. And we can do .saved count. So that's what's actually grabbing that saved count value that was in the save file. So that gets us our number. So that might be something like 13 if it was 13 when we saved our game. The first thing I'm doing here is I'm doing a math min on that value, say 13, and a maximum value. Say the maximum value is 10. What math min is going to do, math is just a library that provides a bunch of math functions. Min is going to, out of the two values I provided, it's going to return the smaller one, the minimum. And so what I'm doing is I'm saying I either want the count or the maximum value, whichever one is smaller. So if this saved value is 13 and my maximum value is 10, I'm actually going to get 10 back because 10 is the lower value. But if the value is below my maximum, I would get the actual value. And so all this is doing is it's constraining it to our minimum and maximum. So if for some reason our maximum, when it got saved, that value is higher than what our maximum now is, it's going to say, hey, we can't have 13. We're going to bring that down to 10 because that's our new maximum. So that's what this is doing, is it's just enforcing the maximum. Once we've done that, this whole expression is now going to be whatever number it picked out of that. And now it's going to do math max on that, which finds the maximum between that result and our minimum value, which is just the opposite, right? It's saying I either want my minimum value or the other value, whichever one is bigger. So if my value is smaller than the minimum, I'm going to constrain it back to the minimum. A little confusing, but it ends up being a very kind of slick one-liner to be able to constrain the value to the bounds. So at the point that this line is finished, count is either going to have the value that was saved or the minimum or maximum if that value happened to be outside of the bounds. So all of that was if we found saved data, right? If we find saved data, we want to load that saved data and store that into count. Otherwise, we're just going to default to the minimum value, which seems like a reasonable thing to do. Like oftentimes that'll be 0 and it would make sense to go to 0. Once we've done that, so we've loaded in our data, if there's any saved data, then we've got two functions here. We've got generate button parameters and create buttons. Now we certainly could, all the code that's in these functions, we could just put in onload and have onload be kind of this long, function with all this code. In general, it's kind of nice to break things into functions. It makes it a little more readable. I can go into onload and be like, okay, I could have made the argument actually that all of this could have been in a function that said, load data and have that be a separate one. Because then it just reads really clean to be like, okay, in onload, we load data, we generate the button parameters, and we create the buttons. And if I want to look at any one of those parts, I can go to that specific function. So the first thing, generate button parameters, I think is way at the bottom of this file. And this one is kind of dense. Generate button parameters. And this is where we're basically building up the parameters that we're going to use to create a button. And almost all of what makes that data up is all of our values that we're allowing, the user to change, all those capitalized values. And really the process that I was doing here is what you would call parameterizing. So I took code that was working and doing, the custom counter tokens properly. And then I said, okay, I want to make a lot of these values really easy to change right up at the top. So instead of hard coding values, instead of having the position here have the numbers for each, I'm going to switch those numbers out for variables and define them up at the top. And so that allows somebody that doesn't want to get into the scripting can go and just change those values. And what they're actually changing is all of the values that are plugged into all these different spots. And so when you create a button dynamically in Tabletop Simulator, in some of my other videos, we've shown how you can create a button in the UI. Here we're actually creating it through code. And when you do that, the create button function is going to want a Lua table. So once again, this is a big Lua table anytime you see curly braces. That has a bunch of just any parameters that there's a bunch of parameters that a button could take, and you supply whichever ones you're interested in using to define that button. So I'm going to skip index for now because that's going to come in a little bit later, but a lot of these other ones are going to make sense. The click function is simply saying when this button is clicked, what function should we run? So that's what actually allows us to attach logic to our buttons. Function owner is just saying this object is the one that function's in, so we use the keyword self to say that it's within this object. And then we got a lot of positioning and size stuff. So we got position is going to itself be another Lua table that's kind of like an XYZ value. I hard-coded the Y because that's what's going to determine it being like further off the table from the token, which I figured wasn't really something you'd be interested in changing. Like, you probably want to be able to move it around kind of relative to the token if you were looking down at it, but it didn't seem worth the effort to kind of expose that as a parameter that you could change. So you've got all the positioning, then we got the width of the button, the height of the button, the color of the button, the font, and the font size, which we actually have a function for here. So I'll touch on that in just a moment. And so even though this is broken over multiple lines, it's still just a Lua table. Like, I could break these lines up however I want. Oh, that definitely, whoa, I don't know what just happened there. But, okay, so you see how I just hit enter here and it put this down here? You know, I don't know why it's freaking out whenever I, that's really bizarre. Admittedly, the Tabletop Simulator code editor is not the nicest thing to work on, and I'd like to do a future video on how to edit the code from Atom, which is a popular code text editor that Tabletop Simulator actually has a direct integration with. But that'll have to be another day, and I might actually click out of this quick because it is giving me some troubles. Okay, let's see if this is a little better. So the point I was trying to make is that you could enter down and put this on a different line, and it would all still work. Like, it's just looking for the comma-separated list of values that are between these curly braces. So I just kind of broke it up to make it somewhat easy to read. We're gonna be fighting against the editor here a little bit, so I might try to not make a lot of changes. But that, so we have this as the value button parameter. So that's the button that's actually showing the number on it, which is going to get back to why we're giving this one an index, whereas we don't for the other ones. These other ones are for the other 4 buttons that could exist, which is a +1 button, a -1 button, and a +5 button, and a -5 button. And these follow a very similar, pattern of how they have all the different parameters. They're linked to a different function, right? Because each one needs to have the correct logic of how much it should be adding or subtracting. And that's all that we're defining here. So this is just setting it all up so that when we go to create the buttons, we can use these tables to generate them. Now, I mentioned that value button parameters has an extra one that the others don't. Well, it's not an extra, I guess. These all have font size. But whereas these ones are using the parameter that the user defined for font size, here I'm doing get value button font size. And the reason for this is we want the font size of our number to be different based on how many digits are in it. So it's if our value is only 7, we can show that 7 nice and big. But if our value is 743, we might need that font to be a little smaller so that it still fits on the button. So what this is doing is it's calling this function to get the font size, which is a function that we defined up here. So here's get value button font size. And all this is doing is it's seeing how many digits are in our current count and then returning the appropriate font size. So if our count is between 0 and 9, then it's going to return the 1-digit font size. If it's from 10 to 99, it'll do the 2-digit, and then 100 to 999 is a 3-digit. Then we also account for negatives here, because -1 is kind of like 2 digits in terms of like the width of it. So we have -1 to -9 is 2-digit, -10 to -9 is 3-digit. In all other cases, we know that we're going to want the 4-digit, which is kind of the smallest font size. So this is just it's just gonna, based on the current count, return one of our font sizes, and then that's what's gonna get stored into font size here. Now that's going to end up coming into play when we update the value too, because you can imagine when we go from 99 to 100, we're going to want the font size to change at that moment from the 2-digit to the 3-digit. So we'll see where that ties in a little bit later. So that's generate button parameters. We get basically all of these variables here, and because these don't have, man, I said I'm not going to type, and then I start. Because these don't have local written in front of them, man, every time I hit any button, it just is throwing me out. We'll just leave it. So because I don't have local written in front of this variable name, that means that this variable is an instance variable that can be accessed anywhere in our script. Like, it's not isolated to just this function. Whenever you see a variable that has local written in front of it, that means that it's only in the scope of this function or whatever block it's currently in. And if you try to access this outside of that, Tabletop Simulator is not going to know what that variable is. And in general, it's good practice to keep variables constrained to where they're needed, like not making them accessible throughout unless you need to. Here, you could argue this isn't the best way to do it, but we're basically just making it accessible anywhere so that when we go to generate our buttons, we'll be able to access these even though they were in this function. So once generate button parameters done, we have all these variables that have the Lua table set up with what we want. So it's going to come back up here. So that finished generate button parameters, and now we're going to create buttons, which is somewhere in here. Probably down at the bottom. Create buttons. So what this is going to do is it's going to set the label of our... So it's going to first add a couple properties to our value button parameters table. It's going to update the label to be the count, the current count. We probably could have just done that in generate button parameters. Same thing with this font size. In fact, this is very redundant. I don't think we need this line because we just did that, right? We just set that to get value button font size. That's not going to have changed. But doing it a second time, I guess there's no harm. And at this point, we're going to create the buttons. And so there's a self.createButton method that you pass a Lua table of all the parameters that the button needs, which was what we defined down here. And that's going to create that button. And so we create our value button, we create our +1, and we create our -1 button. Then we're going to also create +5 button and -5 button, but only if these variables are equal to true. So this is what's allowing you to decide whether you want the -5 and +5 or not. Because maybe you have a game that only goes from like 0 to 10, and having a +5, -5 doesn't make a lot of sense. You're mostly just going to want -1, +1. So you have that option up there to change this to true or false. If it's true, it's going to come in here and create the button. If it's false, it's just going to skip it. And that creates our buttons. So those two things in conjunction set up all the data from for our buttons, pulling from all those parameters the user defined, and then it creates the buttons. At this point, we're loaded, right? Like that was the end of our load function. And so the game is ready to go. And that all happens like pretty much instantaneously, right? Computers are very fast. And so at this point, you're now able to interact with the game and click the buttons. And so what's going to keep the functionality working at this point is the fact that we tied every one of these buttons to a function, which means that if those buttons are clicked, it's going to run the code in that function. So let's look at what our functions up there look like. And they're pretty straightforward. So we've got add 1, which is when you click the +1 button. All this is going to do is we want it to add 1 to the value, but we want to make sure that it doesn't go over the maximum, right? If the maximum is 10 and we're already at 10, we don't want to go to 11, we want to stay at 10. So again, this is just kind of a nifty one-liner to accomplish that. We're going to just ask what's smaller, count +1, us actually adding 1 to the count, or our maximum value. And we'll take that. And that will essentially give us the +1. It'll update it. But if we're at our maximum, if count is 10 and maximum value is 10, then it's going to say, hey, 11 is more than 10, so I'm going to pick 10 and just keep the value at 10. So that updates our count. But that's just the variable in the background, right? Like that's just in our code. That doesn't change anything that the user is seeing. To actually change what they're seeing, we're going to have to update the value by calling this update value function. Now this could have been named, this is a function we're defining to update the value. And if we scroll down to it here, we see update value is basically going to take... It's going to get a new font size. So this is what's going to help us. If we go from 99 to 100, this is what's going to recognize it because it's going to update the font size by going to that function and doing it with our new count value. Then we're going to update the label to actually be the count. That's what's changing what you literally see is the label, changing it from 6 to 7, from 99 to 100. And then, and we're editing those in that parameters table. And then we're going to call the edit button function, which is exactly like the create button function in that we pass it these parameters. The big difference is it needs to know what button it's updating, right? Is it editing, which of our buttons is it editing? And this gets back to why we put the index. So this index is what we're assigning this button a specific index. We're saying this button has an index of 0. And then when we submit it to edit, that table still has index equal to 0 in it. And so that's what's telling it, hey, I'm editing the button that has an index of 0. That's what ties those two things together. And in this case, we only are ever editing our value button. If we were editing multiple buttons, though, we would need each of the buttons to have different indices. We would need this one to have index 0, and this one could have index equal to 1 and index equal to 2, so that Tabletop Simulator can keep them all separate as you're editing and updating them. But this is just our update value, and the reason we put it in a function is because there's a lot of places we're going to want to update the value. Any of the buttons that, add or subtract are going to then want to update the value. So we put all that logic in here to update the font size, update the label, and then apply those edits to the button. So that way, all of these functions up here just all call update value at the end. So they all kind of share that logic. So once I've explained this one, the rest of these look pretty straightforward. This is just kind of the reverse where we're subtracting one. So we want to take the max between that and the minimum value to make sure we don't fall beneath our minimum, and then update. And then the +5, -5 are exactly the same, except that it's going to add or subtract 5, and again constrain it to the maximum and the minimum. The last piece we have here is the allow set from description, which, just to be clear on what we're talking about there, this is what allows you to right click here and come down to the description and say 536. And then if I click this button, it updates it straight to that value. So it's kind of a quick set to an exact value logic. And actually, if you come in here, you'll see that the description is empty. So if we look at how that's working, first of all, we configured our value button way down in the parameters to have the quick function of set count from description. So whenever we click that button, that's the function that it's going to call. So if we come up and look at set value from description, it's going to do a few things. First, it's going to check, is this currently enabled? Because I give the ability that if you wanted to set this to false and not allow you to do this kind of quick setting, then this would literally just do nothing and it wouldn't work anymore. So it just allows you to toggle it on and off. Assuming it's on, though, the first thing we're going to do is we're going to get the description of the object. So this is something that just objects in Tabletop Simulator have through the API, is the get description function is going to return whatever text is in that description field that we right-clicked to get to. And it's going to then store that value in our description variable, which we're making local because we only need it for this logic right here as opposed to like outside of this function. So once we have the description, we're going to say if the description is not empty, so if the description is empty, we don't do anything, right? Because there's nothing to set. So if it's not empty, and this is basically saying if we convert the description to a number, so to number is a kind of a typecast that takes text, which commonly in programming languages would be referred to as a string of characters. To number is going to take that and attempt to convert it into a number. So if we have text that's 546, but it's a string of characters, it will convert it into the actual number, the integer 546. So that's what this does. And then once that's done, we're going to call the type method on it, which type is asking Lua what is the type of this variable. Like if we did type on description, it would tell us this is a string. At least I think Lua calls it a string. Whereas if we do it on a number, it would say this is a number. And so what we're doing is we're saying, okay, if we convert the description or attempt to convert the description to a number, if that type is in fact a number, then we're going to try to update the value. Now, why wouldn't it be a number? Well, we could have typed banana in our description, right? And if we type banana in our description, to number is going to have trouble converting banana into a number. I'm guessing this function probably returns like the nil value. I think it's nil in Lua, which is just the nothing value because it wasn't able to convert it to a number, in which case the type of that would not be number. So if we type banana, it's going to fail this check, and it's not going to try to update it, which is just a nice safeguard to make sure that we're only updating if it is in fact a number. So if we're in here, that means we do have a number to update. So the first thing we're going to do is we're going to update the description itself to be blank. So we're just clearing the description. because we already have the description stored in this description variable, so we can go ahead and wipe it out in the actual description. Then we need to update our count, so we're just going to set count to toNumber of description, which we've already confirmed that this is going to be a number when we did our check here. Now that count is equal to the new value, we do our update value, just the same way that we did any of the other updates of the value. And at that point, it'll update it, it'll update the font size and everything, it'll display it with the new label, and our description will be empty because we cleared it here. And that's how that's working. And that, in fact, is how all of this is working. That is, I think we've touched on every line in here. And so that's that. Hopefully that was, depending on where your reasoning for being interested in this video, hopefully it was interesting to see how it was working, maybe helpful to just better understand scripting in general, or have little pieces that you can apply to things you might be working on. If you enjoyed this video, consider giving it a like, subscribing to the channel for more content like this and other content aimed at game designers. Feel free to leave questions in the comments, and I will see you in the next video.